Hello everyone, my name is Greg and today I prepared for you 5 questions from the latest aircraft general knowledge exam seen the last 30 days across all authorities. Topic for today, hydraulic system. Question number 1. Which of the following sources of hydraulic pressure is commonly used for operation of cargo doors when the electric hydraulic pumps are not working? Hand pump, ram air turbine, engine-driven pumps, or hydraulic accumulator. Usually, when the hydraulic system is inoperative for cargo door operation, aircraft are equipped with a hand pump. For example, in the Airbus A320 family, there are 3 cargo doors, and 2 of them, forward and aft, are hydraulically operated via yellow hydraulic system. When engines are shut down, this system is operated via electrical pump, and if this pump fails, it can be powered by a hand pump located on the hydraulic maintenance panel. So, answer number 1, hand pump is correct. Question number 2. The aircraft system which requires the highest amount of hydraulic flow is the electronic fuel control system, integrated hydraulic regulator, constant speed drive, CSD, or horizontal trimmable stabilizer. For this question, I will just use a method of elimination. First, an electronic fuel control system is electrically controlled and has nothing to do with a hydraulic system. Hydraulic regulator, as the name suggests, regulates the pressure and does not require a specific hydraulic pressure for operation. Now, constant speed drive, even though it's a hydromechanical device connected to the engine accessory gearbox, the amount of hydraulic pressure required for CSD's operation cannot be compared with the one required for trimmable horizontal stabilizer operation. THS being one of the flight control surfaces, as you can imagine, requires huge amount of pressure. So, the correct answer for this question is answer number 4, horizontal trimmable stabilizer. And question number 3. What is the common operating pressure of the hydraulic system on most large transport airplanes? 3000 psi, 3500 psi, 1500 psi, or 1000 psi. Most high pressure systems are operating at 3000 psi or higher. Both Boeing 737 and Airbus A320 families operate with 3000 psi, and some aircraft like Airbus A380 or Boeing 787 operate at 5000 psi. In case of A320, all 3 hydraulic systems, green, yellow, and blue, normally operate like I've mentioned before, with 3000 psi. However, in case of emergency and total loss of electrical power, ram air turbine can pressurize blue system at approximately 2500 psi. So, for this question, let's select answer number 1, 3000 psi, and it's a correct one. Question number 4. When powering up a hydraulic system, the level in the reservoir will increase as ambient temperature decreases, always remain the same, decrease slightly, or initially increase with system pressurization. Okay, so during normal operation, it's quite common to observe some variations in the level of hydraulic fluid. The fluid level depends on many factors like position of actuators, accumulator charge, pressure, or temperature for that matter. After engine start, the fluid is pushed along respective hydraulic systems to the actuators and accumulators, and a slight decrease in quantity is considered as something normal. It happened not only after engine start. For example, in A320, after landing a retraction, we can also observe a decrease in hydraulic fluid quantity in the respective hydraulic system. So, coming back to the question, the correct answer is answer number 3. With powering up a hydraulic system, the level in the reservoir will decrease slightly. And this answer is correct. Now, the last 5th question. The function of a hydraulic fuse is to protect against contamination, prevent total system loss in the event of a hydraulic leak, switch the secondary system in the event of a leak in the primary brake system, allow bypassing of the hydraulic pump in the event of excessive pressure. So, hydraulic fuses are designed to prevent total fluid loss and to protect functionality of components that are upstream of the fuse. Most of the fuse designs work on the principle of pressure differential. If downstream of the fuse the flow becomes excessive and therefore pressure rapidly decreases, a small piston inside, acting under a spring pressure, will seal the fuse and secure all upstream components. So, the correct answer will be answer number 2. The function of a hydraulic fuse is to prevent total system loss in the event of a hydraulic leak. And this answer is correct. That was all for today. Thank you very much, and hopefully see you next time.